Welcome to part 2 of section 3.3, continuing our work with completing the square. Wondering what to do if you have a leading coefficient. So what I mean by a leading coefficient is instead of a 1, you have a different number than 1 as your leading coefficient. So we start the same way as the other one. We group the first two terms. Now at this point it gets slightly different. What you're going to do is divide this group of 2 by a common factor, the greatest common factor, but not the x. So what they have in common here is 3. So I would factor out 3 from this group. Divide everything by 3. And you're left with 3 bracket x squared minus 4x, subtract 9. Next step is very similar to the one without a leading coefficient. We think about what is half of this term, which is 2. So we're going to add the square of that, positive 4, and subtract the square of it, minus 4. Next step, group the perfect square trinomial. Now at this point you'll notice that I'm using a square bracket as well, and that is because of one extra step we'll need at the end. So I use a square bracket here at the beginning to keep the negative 4 within that square bracket, but group the perfect square trinomial as normal. Refer back to your notes from grade 10 how to factor this perfect square trinomial to make it a binomial. Remember the tricks that we learned from yesterday. So, x minus 2 squared is the factoring out of this trinomial. X minus 2 squared. Now I still have my square bracket because at this point I need to do the distributive property before I can simplify. So I'm going to go doing 3 times negative 4 in my next step. So you can see here I'm doing the distributive property. 3 times negative 4 makes negative 12. And the final step will be to simplify negative 12 and negative 9 to be negative 21. This is now in vertex form. Started off in standard form, and it is now in vertex form. Remember, you can always check to see if you're right by multiplying this back to see that you get the same answer as you started with. Okay? So we'll try a couple of these. I'll do a couple as a model, and then you can try some on your own. Following the steps, this first one is the simplified one. It has no leading coefficient. So I follow my steps from the original version. Group the first 2 terms. Take half that number, which is 3, and add and subtract the square of it. So when I square 3, I get positive 9 and negative 9. Now, make your perfect square trinomial. Turn that into, factor it by getting the binomial term. So remember the trick. You take half of the middle number, use the sign from in front of it. And simplify negative 9 plus 5 to give you negative 4. And that's your final answer. B. Now B does have a leading coefficient. So we are going to start off the same way by grouping the first 2 terms, But next I'm going to divide out the common factor, which in this case is 3. And you're left with x squared minus 4x minus 9. So on your next step, take half of that term, which is 2, and add that square. 2 squared is 4, and subtract the square. Next, use a square bracket as you group your perfect square trinomial so that you keep the -4 within that square bracket for now. Next, you'll get your perfect square binomial, which is x minus 2 squared. Don't forget, you still have the -4. Now you will use the distributive property. Three times -4 is -12. And final step, simplify. And finally, with C, we have y equals -5x squared minus 70x. So again, this is a coefficient one. It has a leading coefficient, so group the first two terms. Divide out the common factor, which in this case is -5, and that leaves us with x squared plus 14x. Next, we're going to take half that term, which is 7, and square it. Add the square and subtract the square. And there is no C value. Now, make a square bracket, group your perfect square trinomial. On the outside, you keep the -49. Close your square bracket. And now, we can go to our perfect square binomial from here. X plus 7 squared minus 49. And as our final step, we need to use the distributive property here. And -5 times -49 is going to give us positive, what's that, 245. And you're done. So you should try those on your own. Pause here and try those 3. I'll pull out the answer. You should get those for an answer. Now, we're going to be skipping over, you can try those from the book as well, but we will be skipping over example 2 and 3. And going into the story problems. So you should pause again here and try this one on your own on page 180, number 1 to 5, to see how a story problem works. And then we're going to do this one together. So these types of problems, like I mentioned yesterday, these types of problems are prevalent in the business world, where you'll need to, as a business manager or a CEO, be able to maximize your revenues, or whether it be minimize your costs or use your inventory correctly. These questions are all going to be very similar. What can I do to maximize my revenue? So here we have a student council. They want to make some money. Last year they did photos and they charged $10 for each fee, and there was 400 sessions booked. So now they're trying to see if they could do better. They wonder what they should charge this year to still maximize the revenue. And they've discovered that as they increase the price by $1, they expect to have 20 fewer sessions booked. Okay? So there's a lot going on in this question. So the first thing I want you to sort of understand is that revenue, if you're not quite sure of what revenue is how much money you make. So basically it means you take the price and multiply it by the number of sessions. That's how you get profit. So last year, their revenue was, they charged $10 and they booked 400 sessions. So the revenue was $4,000. They want to know what they can do this year. So what we need to figure out is we need to be able to represent price in some way. How can we represent price? And how can we represent number of sessions? Okay. So we need a little expression to represent these. Okay? So to do this, I'm going to let x represent something first. Let x represent the number of price increases. So feel free at this point to think about it common sense. So if I raise my price from $10, and it says if I raise it by 1, so let's say $11. My new price is 11, I'm going to lose 20 customers. I'll only have 380. So my revenue is going to change a little bit. Instead of having 4,000, I'm now going to have 11 times 380. Okay? And so on. If you increase it 2 times, so up to $12, then you will have only 360 sessions. So your revenue would adjust accordingly. Okay? So, but we can do that common sense approach and keep going until we figure out how many price increases would it take before I maximize the revenue. Okay? So with a price of 11, I would have 4,180, so that's good. With a price of 12, I'm going to have 20 fewer, but 4,320. With a price of 13, I'm again losing some customers for 420, and so on. But I need a better way to do that. So I'm going to let price be equal to this, because it originally was $10, and I'm going to increase it by 1x. I don't know how many price increases I'm going to do yet, but x is representing how many there's going to be. There could be 1, 2, 3, we don't know yet. The same thing I'm going to do over here under sessions, number of sessions. Well, we originally had 400, but for every price increase, we're losing 20 sessions. 20 times the number of increases I do. If I do 1, I'm losing 20 people. If I do 2, I'm losing 40. 3, I'm losing 60, and so on. So earlier, I had set up revenue to be, remember, price times the number of sessions. Well, this is what price is being represented as. 10 plus x, still price, new price, and my sessions is 400 minus 20x. Okay? So if I FOIL this, multiply it, I am going to come up with a quadratic equation. So let's do the FOIL. 10 times 400 is 4,000. 10 times negative 20x is negative 200x. X times 400 is positive 400x. And x times negative 20x is negative 20x squared. So I'm going to put it in standard form. So the negative 20x squared goes first. I simplify this to make 200x plus 4,000. Now it's in standard form, A, B, C. And that is what they're asking us for. Write a function, so that's part A. Part B, what is the maximum revenue they can expect based on these estimates? What session fee will give that maximum? So what are they asking for in that question? When they say, what is the maximum revenue? They're not coming right out and telling us, but what mathematical part are they looking for? It's the vertex. The vertex will represent the maximum revenue. So let's figure out how to do the vertex. Well, to get the x coordinate, and in this case, what does the x represent? X represented the number of price increases, okay? So we'll do negative b over 2a, negative 200 divided by 2 times negative 20. So you'll end up with negative 200, negative 40, and that will give us an answer of 5. 5 price increases is the ideal number that you should increase by. It's not a price of $5. It would be a new price of 15, right? Because X represented the number of price increases. So now I'll find my Y, and in this case, Y represented revenue. And we do C minus AP squared. So C was 4,000 minus negative 20, and the P we just found was 5. So we solve this. So we have 4,000 plus 500 So if we write this in the sentence, the maximum revenue is $4,500. And the other part of the question they were looking for was, what session fee will give that maximum? Not just the number of increases. The session fee remember the price? So we go back to our price. Low price expression was 10 plus X. So 10 plus 5, which is $15. A session fee of $15 would maximize our revenue at $4,500. Okay, and how can you verify the solution? Well, you can verify the solution by completing the square. By completing the square to find the vertex. Okay? And finally, what assumptions did you make? Okay, well, I assumed that it would be a constant increase constant decrease, that it would exactly be 20 people each time. Okay, and that's not always the case. Something else may be at play there besides just price. Okay? So that's how a story problem would work using a quadratic function. So you should try this one on your own. Pause it here. Okay? And then we'll do this one together. So, a sporting goods store sells reusable water bottles for $8, and they sold 100 items. Research says that for every $2 increase in price, the manager can expect to sell 5 fewer water bottles. So just as a sort of a common sense, so if I raise my price from 8 to 10, now it's $10, I'm going to sell only 95 items. So I'd be making $950. My revenue's a little better. Then I increased it another $2, so now it's 12, and I'm down to 90. Well, my revenue is 1,080, and so on. What should they expect to sell to maximize this? So, again, we need a way to represent price and items. So again, let X be the number of increases. So revenue then is basically, we want an expression to represent price times items. How will we represent each of those things? Well, revenue is going to be represented by the original 8 plus 2 times the number of increases. So if it was 1, it would be $10. If it was 2, $12. Times, we originally had 100 items, but we're going to be losing 5 for every increase. And that's how you set it up, and then we multiply to get our answer. So you would get 800 minus 40x plus 200x minus 10x squared. Rewrite it in standard form. Simplify that would be positive 160x plus 800. And there is part A, revenue, and quadratic function. Part B, asking you, same thing, what is the maximum revenue? So they're looking for the vertex here. So we need to find x first, negative b over 2a, negative 160 divided by 2 times negative 40 divided by negative 80. So that's going to give us 2. 2 price increases is next. Okay? So basically our price is going to be $12 because after that it's going to be too much. Because after that you're going to be down to you're back down the other side again. Okay? Oh, sorry, I made a little mistake here. Let's go back a second. I put the wrong a value in. I'm thinking that seems very short. So I would need 2 times negative 10, sorry, not negative 40, and that would be negative 20. So we have 8 as our answer, sorry. Next we're going to do the y value, which represents the revenue, c minus ap squared. The c value is 800. My a value is negative 10. My p I just found is 8. So we have 800 plus 10 times 64, or 800 plus 640. So our maximum revenue is $1,440. 8 price increases. Well, we can increase this quite a bit. So we can increase this water bottle 8 times, $2 each time, 16 bucks we could increase it by, and people would still buy it. Okay? So, part B, let's just make sure we're asking for what selling price will give that maximum revenue. So the selling price, remember our little expression from earlier, was 8 plus 2x. So I just found my x was 8. And that's going to give me 8 plus 16, $24 I can sell this for. All right, so $24 times the number of water bottles we would have. How many water bottles would you sell? Well, the number of water bottles would be this one. 100 minus 40. You would sell 60. Okay. And part D is just the assumptions again. How you can verify it is using the complete the square method. And for homework, you should practice these. Some of them are drill questions and some of them are story problems. Thank you.